Hi and welcome to assignment 7 of topic 3. And in this exercise we're being asked to calculate the factorial. Now we have to ask for a positive number as input and output its factorial, and so we need the definition of a factorial. The factorial of a number n, written n exclamation mark, is nothing more than a very long product of all numbers from n down to 1. So for negative numbers, the factorial is not defined. In this case, you can simply print does not compute. I already took the liberty to have an io.read here parsed to an int for our number n, and I'm going to just call it n, as it's very common in mathematics. So what do we need to do? We can say if n happens to be smaller than 0, then we have to print io.write here for does not compute. Okay, there we go. And in the else case, I need to, of course, do some real work. So let's just build a block, because we're going to do several things here. I have to set up some accumulator. Instead of a sum, it's going to be a product. So let's make a variable product, which we have to start at some number. 0 is a bad number if we are going to multiply, so let's start with the neutral element being 1 for multiplication, and then we have to count from n down to 1, okay, or from 1 up to n, and we just have to multiply all these numbers onto the very big product. And I'm letting me guide by the code pilot here, which makes me a fine, nice for loop, starting at 1, going up to and including n, 1 by 1. And I'm going to I'm going to multiply upon product whatever I is in this case. So all these i's from 1 to n are multiplied with product. Now I could try and test this already. Let's see what this brings us. And this is not okay yet. So first test is okay. Second test is for 0, this should be 1. Okay, so this is nowhere in the assignment, but it's part of the mathematical definition of factorial. So zero exclamation mark is 1 by definition. Okay, and you can figure out why, because there's also a recursive definition of n factorial, which is nothing more than n times n minus 1 factorial. And so given this recursive definition, it must be that in the end, if we get to 0, this must be 1, or otherwise the whole multiplication would be 0. Okay, I'm not going to go into this any further, but well, let's see what happens if we have 0. If someone enters 0, we're getting into the else. And of course, well, I think it's okay because I start a product at 1, but what I didn't do is just write the result, of course. Okay, and that's probably why the test didn't run. Let's see. Now we're good to go. This is the solution to assignment 7, but there's something we can say here. We don't like, remember, indents. So going to the right, indenting and having new blocks tears down readability, decreases readability. Can we do better? Yes, we can. We could say we're going to take all of this outside of the if. Voila. And in the case that the number is negative, what's going to happen? Well, if I start at 1 and n is some negative number or even 0, then the loop is not going to go and run even once. Because if I have to start at 1 and I test 1 being smaller than 0 or anything negative, this is going to be false and I'm going to jump right here. Okay. Of course, this I only want to do in the case that I have a truly positive or 0 number, and then I don't need these curly braces here. So let me first check if I didn't break anything. Seems okay. And this is a better version of the program. Why? Because now I'm doing again things in sequence instead of going inside structures, going inside the if or the else with a for. I'm building my program sequentially, and that's a better thing to do. Now you might wonder, writing the program like this, is this going to be less optimal? Well, let's see what happens. Given the fact that I'm going to do this anyway, and not conditionally, as in the first version, this might give me some extra work that could have been prevented checking first if n is smaller than 0. Well, let's see what he's doing. He's creating a variable that's going to be killed off anyway here, and we have an assignment. So this is hardly something to worry about if you optimize. But even the for loop is not actually a for loop, because in the case where n is smaller than 0 or equal than 0, the for loop is never going to run. He's just going to do a first check, seeing that I, being 1, is smaller, well, in this case, not smaller than 0 or something negative, so this is going to be false, and the for loop is not going to run even once. Okay, so it's not a really big burden on optimization and speed. This is it for assignment 7, Factorial.